So, good morning, friends. My name is Sah Nirav Kumar, Urfe Nirav sir, and you are with the Jain classes. So, last few days we are starting this series that is called video series about the some lectures or that few topics we are dedicated or deliver the speech on that topic. So, today we are discussing the next topic is called dielectric. So, to understand the dielectric, we are know some fundamental properties. First one is electric field intensity. It is the measure the strength of the electric field, or it is the force on a unit positive charge. In a uniform field, intensity is constant, and in a radial field, intensity decrease because of the distance from the central charge increase. For the radial field, E of E is equal to 1 upon 4 pi epsilon 0 Q upon d square. Next is called electric flux. So it is the rate of flow of the electric field through a given area. So for third one is dielectric constant or relative permittivity. So permittivity is ability of a material to be polarized by an electric field. If electric field is low, then permittivity is also low. So that is low ability to polarize or hold the charges. If relative permittivity is high, then dielectric constant is also high. So that is called very good insulators or isolating signals carry conductor for each other. So next is polarization and polarizability. So a pair of equal and opposite charge separated by a small distance is known as electric dipole. So product of magnitude of one of the charges and the distance between the two charges is known as the dipole moment. So polarization P is electric dipole moment per unit volume. So the dipole moment of an atom of a dielectric material is directly proportional to the electric field applied to the atom. Next is type of polarizations. So when an electric field is applied on a dielectric crystal, then the positive charge of atoms and molecules are displaced along the field, while the negative charge in the direction opposite to that of the applied field. So if your unpolarized atom is there and the polarized atom is there. So first one is called orientation. So if we apply the electric field on the material is going to be polarized. This phenomena is called orientation polarization. B is ionic polarization. So polarization in an ionic crystals arise due to the displacement of ions from their equilibrium position by the force of an applied electric field. So these materials are already polarized because of the negative and positive charge are separated. Third one is electronic polarizations. In the absence of an applied electric field, atom will be spherical. Atom consists of a point nucleus of charges, that is positive Ze, and surrounded by the symmetrically by an electric cloud of charges, that is minus Ze, in a spherical radius r. Next is internal field or local field. Solids, the atoms or molecules experience not only the external applied electric field but also the electric field produced by the dipole. So this field is called the local field or an internal field. So for local field is calculated by the method of the Lorentz. So a small spherical region of the dielectric with an atom at the center of the sphere for which the local field is to be calculated. So the electric field at the center of the sphere E local is equal to E0, that is E orientation, plus EP, that is E polarization, plus ES, that is E spherical, and EM, where M is magnetic dipole. So total field E local is equal to E plus P upon 3 epsilon 0, that is called the Lorentz relation for local field. Next is the Clausius-Mosotti's equations. So it is valid for the elemental solids, it is difficult structure or 4 valence electron like diamond, sulfur and germanium, which do not have ions or permanent dipole moment and have a cubic structure, for which Lorentz field is applicable. So if we calculate this, n alpha E divided by 3 epsilon 0 is equal to epsilon r minus 1 divided by epsilon r minus 2. So it is known as Clausius-Mosotti's equations, and it is valid only for elemental solids having cubic structures. Next is called capacitors. So two conducting plates separated by a dielectric. So if C0 is equal to capacitance of a capacitor with the vacuum between the two conducting plate, then the capacitance C. So epsilon r greater than 1, the capacitance increase on introducing dielectric between the conducting plate of a capacitor. Capacitance of a parallel plate capacitor with vacuum between the plate is given by C is equal to epsilon 0 A divided by D. If the space between the two plates is filled with the medium of dielectric constant epsilon r. So the energy stored in a capacitor E is equal to 1 by 2 CV square. So there are 4 types of capacitors are there. First is single layer capacitor. So it consists of a thin layer of dielectric sandwich between the two metal foils. Commonly used dielectrics are paper, plastic, mica, ceramic or polymers. Second is multi-layer capacitors. Alternative layer of a dielectric and metal alloys electrodes. Ceramics are generally used as a dielectric material in these capacitors. Third one is polymer film capacitors. So dielectric materials are polyesters, polypropylene, polyphenol sulfide and polyethylene naphthalene. And fourth is electrolytic capacitors. So either an aluminum or titanium plates with an oxide dielectric layer. Second electrode is a liquid electrode connected to the circuit by another plate. So in the form of a thin foil, electrolyte capacitor have very high capacitance. So they are polarized and have to be connected with the proper polarity. Next is the types of dielectric materials. First one is solid dielectrics. The solid dielectrics are most commonly used. These are very good insulators. Porcelain, glass, plastic, rubber, cotton, wood and mica are the example of this solid dielectric materials. Second one is called liquid dielectric materials, are basically of 3 different types, which include first mineral insulating oils, B synthetic insulating oils and C miscellaneous insulating oils. The function of insulating liquid is due to provide electrical insulations and to dissipate the heat. Example of transformer oil, cable oil, capacitor oil, vegetable oil, Vaseline, silicone, liquids and Soval and Sovatols. So these are the example of the liquid dielectrics. Third one is gaseous dielectrics. So gaseous dielectric materials are used both as insulator as a cooling agent. Examples are air, hydrogen, nitrogen, helium, sulfur dioxide, propane, methane, sulfur hexafluoride and ethane. So if you consider the first solid dielectrics, the example is mica. So it is an inorganic mineral materials made up of the silicate of aluminum with silicate of soda, potash and magnesia. So it is a crystalline in nature and can be divided into very thin flat sheets. It is a rigid, true and strong. It has high dielectric strength and low dielectric loss. It is not affected by moisture. It is widely used in electric irons, hot plates and toasters for insulating purpose. So it is used as a dielectric material in high frequency applications. Second, EB, that is glass. So it is inorganic material made up by the fusion of different oxide like SiO2, ZnO and MgO. Glass is brittle and hard. It has good mechanical strength and low dielectric loss. Insoluble in water and is highly chemical resistant to most corrosive agent. Used as a dielectric in capacitor, it is used in radios and TV tubes, electrical lamps and laminated board. Second is liquid dielectrics, a mineral oil that is flammable and common type of transformer oil. B. Castor oil, high dielectric constant, flammable, refined and dried castor oil is used in some high voltage capacitors. C. Silicon oil, more expensive than hydrocarbons, less flammable. Purified water, high thermal capacity, good cooling properties, low electrical conductivity when free of ions. E. Liquid argons, cryogenic, its main purpose is to prevent or rapidly quench electric discharge. They are used as electrical insulators in high voltage applications. And gaseous dielectric, sulfur hexafluoride, that is SFC, most populating insulating gas. It is dense and rich in fluorine, which is a good discharge quench, good cooling properties, excellent arc quenching, corrosive decomposition produces. Second is nitrogen N2, often used at high pressure, does not facilitate combustion, non-electrical attaching, efficient in slowing down the electron. And C is air, breakdown voltage 30 kilowatt per centimeter at 1 atmosphere, very well researched when subject to an electrical discharge from corrosive NO2 and other compounds, especially in presence of water. Corrosive decomposition products can facilitate combustion, especially when compressed. So this is the main structure of this dielectric material. If you like my videos and if you like my content, then you can like the Jain classes. My name is Nirav sir. So if you like my video, then you can subscribe my channel. If you do not like my video, you do not subscribe my channel. So thank you for watching this video. For more type of these videos, so basically I made the videos for the students who have the engineering background. So for these things it is electrical or electronic purpose only. So this dielectric material are used for the students who are studying in electrical engineering or electronics engineering. They are only use or they are know about the dielectric materials. So each and every video and each and every topic have some specific field. So that field students are only that field people are only understand that particular thing. This video is only for that particular peoples, not for all. So if you watch the video, first be secure that it is video that is dielectric is only for the electrical or electronics people only. If you are from another field, then you do not understand anything about this because you do not have the proper background about this dielectric field. So thank you for once more watching my video, and if you like my channel, then you can like it. The channel name is Jain Classes.